MCA Prep Day 3. Our first benchmark is 8221. Represent linear functions with tables, verbal descriptions, symbols, equations, and graphs. Translate from one representation to another. Part A says use the table to find the equation for the linear function. For this benchmark, what I'm going to do is I'm going to take the information in the table and draw a graph. Because I think that it's easier to find your equation from a graph. Okay, my first ordered pair in the table is -2, -10. The second one is -1, -6. Remember that you need to graph your x-coordinate first, so you go across first for the x-axis. My third ordered pair is 0, -2, and the fourth one is 1, 2. So if I connect these points to make my line, looks about like this. Now, from my line, the two things that I need for my equation are the slope and y-intercept. The slope of the line will go in front of the letter x in my equation, and the y-intercept will go after it, slope-intercept form. So my y-intercept is right here at -2. To count my slope, I rise 1, 2, 3, 4, and run 1. So rise 4, run 1. 4 divided by 1 is 4. So my slope is 4. So my equation now would be y equals 4x minus 2. The slope is positive 4, rise 4, run 1, up 4 over 1, and my intercept was -2 on the y-axis. A verbal description of the function would be, this is a linear function, because my graph was a line. And I could describe it by saying it has a slope. So with a slope of 4 and y-intercept -2. So that's just giving more details about the graph or about the function. Our next benchmark is 8222. Identify graphical properties of linear functions, including slopes and intercepts. Know that the slope equals the rate of change and that the y-intercept is 0 when the function represents a proportional relationship. So the first question is, what is the slope of the line shown? So slope is rise over run. So I rise 1, 2, 3, 4, and run 1, 2, 3. So my slope is 4/3. Remember, when you count your slope, you can pick any 2 points that are on the line. You start at the one on the left, though. It's just like reading a word. You read words from left to right. You count your slope from left to right. This benchmark mentions up here proportional. This would not be proportional. This would be non-proportional. I know they weren't asking for that information, but this one would be non-proportional because it's a line, but it does not go through the origin. So line, but does not go through 0, 0. All right, so this is a linear function, but it's not proportional. What are the x and y intercepts? Well, the x-intercept would be -3, because that's where the graph crosses the x-axis. So x-intercept is x equals -3, or as an ordered pair, that would be -3, 0. The y-intercept, where it crosses the y-axis, is at 4. So the y-intercept is y equals 4, or as an ordered pair, 0, 4. Now, something that's important for you to understand, so that when you're finding the x and y intercepts from a graph, it's very easy to see them. But remember, if you're looking at an equation, you may want to consider plugging in 0. So like, for example, an x-intercept has a y-coordinate of 0. So you could always plug in 0 for y and solve it in your equation. You might remember that from earlier this year when we had equations like this in standard form, and you would plug in the 0. Like to find the x-intercept, you would plug in the 0 for y, like this, and you would solve it. So you would cancel out 3 times 0 is 0, and then you could divide by 2, and you'd get x equals 3 for that example. So that doesn't match this line, but just to kind of remind you what it looked like when you found intercepts from the equations. And then similarly, the y-intercept has an x-coordinate of 0, so you could substitute 0 wherever the variable x is and solve your equation to get the y-intercept. Okay, our next benchmark, 8223. Identify how coefficient changes in the equation f of x equals mx plus b affect the graphs of linear functions, and know how to use graphing technology to examine these effects. So that means that you need to know how to graph these on a graphing calculator and examine the effects. So the graph of the equation f of x equals 2x plus 4 is a line. What could be the equation of a line steeper than this line? So if you graph this on your calculator, here's what it would look like. F of x equals 2x plus 4. So it would start out at 4, the intercept, and the slope is 2. So you rise 2, run 1. So up 2 over 1, or down 2, back 1. So here's the initial line. Now the question is, can you find an equation of a line that would be steeper than this line? Steeper. Steeper means like more uphill, more uphill. So I know what's going to make it steeper is increasing that slope. So if I increase the slope to 3 instead of 4, and take a look at, or 3 instead of 2, sorry, and take a look at my new line, I'm keeping my intercept 4, but instead of going up 2 over 1 for my slope, I'm going to go up 3 over 1. So that would be right here, or down 3, back 1, right here. So you can see that I've increased the slope of the line. So the coefficient that they're talking about here, to make your line steeper, the coefficient is the slope. Because the slope is the number in front of x, and that controls the steepness of your line. So if you have a slope of 2, anything higher than 2, 3, 4, 5, 6, is going to make your line steeper. Part B says, what could be the equation of a line that has a y-intercept above the line? Well, this is changing the other part, because the y-intercept, so not the slope, but the y-intercept is positive 4. So if you need above that, that just means any number higher than that. So I will pick 7. So f of x equals 2x plus 7. That would have a y-intercept above the original line. Our next benchmark is 8224. Represent arithmetic sequences using equations, tables, graphs, and verbal descriptions, and use them to solve problems. So remember that arithmetic sequences have this general form, f of x equals mx plus b. Remember that b is your y-intercept, or the first term in the sequence, or the starting value. So first term in the sequence, or starting value, or y-intercept if you're looking at a graph. And then remember that m is the common difference. So the amount being added or subtracted over and over, or it's the slope of your line, or the rate of change. So a lot of terms that are interchangeable here. So how much is going up or down each time? Okay, so now to this problem. Emily and Aaron bought supplies and set up a lemonade stand. They charged 50 cents per cup of lemonade. The equation f of x equals 0.50x minus 16 represents the amount of money earned by selling x cups of lemonade. Part A, how much money did Emily and Aaron spend on supplies before they sold any lemonade? If you analyze this equation, hopefully you recognize that the starting point is the negative 16. So that means that they spent $16 on supplies. Spending that money makes it a negative. So they haven't made any money yet. They buy their supplies first. So they spent $16. Part B, Emily and Aaron sold 80 cups of lemonade. How much money did they earn? Well, X, in reading the problem up at the top, X cups of lemonade. So X, the variable, represents the cups of lemonade. So we can plug in 80 where the X's are in the equation like this and solve it. So 0.50 times 80 is 40. 40 minus 16 is 24. So they made $24 profit by selling 80 cups of lemonade. Our last benchmark for today is 8225. Represent geometric sequences using equations, tables, graphs, and verbal descriptions, and use them to solve problems. So, number one, in the year 2010, the population of Edina, Minnesota was about 45,600. Suppose that the population is predicted to double every 10 years. Write an equation that can be used to predict the population after X 10-year periods. Okay, so this is a geometric sequence because it's talking about doubling, and doubling means multiplied by 2. So geometric sequences have this general form, f of x equals ab to the power of x. Remember that a is the first term, or starting value, and b is the common ratio, or what it's multiplied by each time. So, common ratio, or what it's multiplied by each time, and because this one is doubling, it's being multiplied by 2. So f of x equals, our population starts at 45,600. It's doubling, so that means times 2 to the power of x. That x is an exponent for geometric sequences. The x is an exponent. Now, what is the predicted population of Edina in the year 2040? This is our tricky question. So the year 2040. Well, X represents 10-year periods. So 2010 to 2040 is how many 10-year periods? So 2010 to 2020 is 1, to 2030 is 2, to 2040 is 3. So this is 3 10-year periods. So that means that we are evaluating f of 3. So 3 10-year periods. So 45,600 times 2 to the third power. So that gives us a population of 364,800 people in the year 2040.
Did you? Good. Good job. Yeah, I think if you log out, log back in, it will be fine. But do the linear, nonlinear one. That one should be easy. Linear means it's a line. Nonlinear, it's not a line. And remember the things that make it nonlinear, Max, when you have exponents like x to the second or x to the third or 3 to the x power, if you have an exponent that has a letter in it, that makes it curve. Okay? Or if you have a fraction with the letter on the bottom, that makes it curve.